Welcome once again to this space. So here we're going to discuss or we're going to look at how to solve this past question, which was in 2020 WASSCE. So the question goes this way: that in an experiment, 3 coins were tossed at the same time. A. Determine the sample space for this experiment. B. List the event of tossing Roman number 1, exactly 2 tails. Roman number 2, at least 2 heads. Roman number 3, no head. Then we have C. That we should find the probability of obtaining Roman number 1, exactly 2 heads. Roman number 2, at least 2 heads. So now, solution, let's solve this. Now, to determine the sample space for this experiment for tossing 3 coins at the same time. First of all, you can use a table or what we call probability tree, but in this case, I will go directly to use the table to get the sample space for this experiment. So now we all know that a coin has 2 faces, which we usually label head and tail. So if you have 1 coin, then you have another coin, head and tail. Head and tail. If you have 1 coin, head and tail, another coin, head and tail, and these coins are tossed once or at the same time, we are saying that the sample space for this will be head, 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 tail, tail, head, and tail, tail. So this will be the sample space for throwing 2 coins at the same time. Now, if you have this, that is, let's get this, the head, head, the head, tail, the tail, head, and the tail, tail as your sample space for throwing a coin 2 times. If this is the sample space for throwing a coin, 2 coins at the same time, then we are adding another coin. So that coin will also come with its 2 faces. That is head and tail. That coin will also come with its 2 faces, head and tail. And so, with the 2 faces being added to this space for throwing 2 coins at the same time, you are not going to have your sample space for the 3 coins. Throwing the 3 coins at the same time, you are not going to have head, head, and head. You're going to have head, head, and tail. Then you have here, let me rule the lines. So you have here head, tail, and head. Then head, tail, and tail. Tail, head, and head. Then you have tail, head, and tail. Then tail, tail, and head. And the last one will be tail, tail, tail. So throwing 3 coins at the same time will give you this sample space. And so the answer to our A, let's use capital S to represent our set of sample space for throwing the 3 coins at the same time. And so the sample space will be head, 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 comma, head, head, tail, comma. Then we have head, tail, head. Then we have head, tail, tail. Then we have tail, head, head. Then we have tail, head, tail. Then we have tail, 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 head. Then we have tail, tail, tail. So this will be the sample space. This will be the sample space for throwing 3 coins at the same time. Now, if you count the number of sample coins, you have 1, 2, 3, 4, 5, 6, 7, 8. 8 sample points. The number of sample points for throwing 3 coins at the same time will be 8, and this will be the sample space. So that is the solution to A. Now let's move on. B, thou should list the event of tossing Roman number 1 exactly 2 tails. So B, Roman number 1. Events for tossing exactly 2 tails. So let's see, let's represent this with capital E. Event for tossing exactly 2 tails. Exactly 2 tails. Now you look through the sample space and look out for sample points that contain only 2 tails. That contain exactly 2 tails. So look out for it. So here we have one here. So we have head, tail, tail. Then we have tail, head, tail. Then we have tail, tail, head. And this will give you the event for throwing exactly 2 tails. That is a sample points that contains exactly 2 tails. So this is what we have. So we have 1, 2, 3 sample points making up the event for throwing exactly 2 tails. Now Roman number 2, we have thou should list the event of tossing at least 2 heads. Event of tossing at least 2 heads. So let's say capital T. Let's use capital T to represent that. Events for tossing at least two heads. Events of tossing at least 2 heads here means that sample point that contains 2 heads or more than 2 heads. 2 heads or more than 2 heads. In that case, the point that will represent this event will be head, 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 comma. Then we have head, head, tail, comma. Then we have head, tail, head. Then we have tail, head, head. And these points, if you look through, it stops it. The remaining doesn't contain 2 or more heads. And so this will be the event for tossing at least 2 heads. At least 2 heads, I said earlier on, means 2 heads or more. And so you have 1, 2, 3, 4 as our sample points representing the event for tossing at least 2 heads. Now move on. Roman number 3, no head. Event for tossing no head. Roman number 3. No head. So Roman number 3, no heads. So look through the sample points that doesn't contain any head. And so if you look through, you will realize that this point here, tail, 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 is the only sample point that represents event of tossing no head. Event of tossing no head. So we are done with B. Now let's come to C. So the C, you continue, then they said find the probability of obtaining exactly 2 heads. Find the probability of obtaining exactly 2 heads. Here, you don't have any event for tossing exactly 2 heads. So we look out for that. So C, Roman number 1. We first of all look out for event for tossing exactly 2 heads. So event for tossing exactly 2 heads. Let's look out for that from the sample space. Event for tossing exactly 2 heads. We have this one, this point, head, head, tail, comma. Then we have head, tail, head. Then we have tail, head, head. And that is all. So these events, these sample points represent the event for tossing exactly 2 heads. And so we use that to find the probability of tossing exactly 2 heads. So now our probability of tossing exactly 2 heads, probability of T, which we use to represent the event for tossing exactly 2 heads, will be the number of sample points in the event for tossing exactly 2 heads. So we count the number of sample points inside that set. 1, 2, 3. So 3 divided by the number of sample points in the sample space, which we already calculated, and we have 8. And so event, the probability of tossing of the probability of obtaining exactly 2 heads will be 3 out of 1, number 2, and the C. It said that we should find the probability of obtaining at least 2 hairs. Probability of obtaining at least 2 hairs. Now we have found in B, II, the event for tossing at least 2 hairs. We have found that in B, II, the event for tossing at least 2 hairs. So we can easily use that one to find the event, the probability for obtaining at least 2 hairs. And so we count the number of sample points in that event. So we count 1, 2, 3, 4. So we have 4 out of the sample points in the sample space, which is 8. And so simplifying this further, we will have 1 out of 2, or 1 divided by 2, as our probability for obtaining at least 2 hairs. And so let's continue to follow, subscribe to our channel for more interesting past questions on this page. See you in our next video.